Hey there folks! Today I'm going to be teaching you how to solve the 3x3x5 cuboid non-proportional from Cube for You. First, let's get used to this cuboid. We're going to need to know the names of all the pieces on this cuboid and what they are used for. These pieces right here are inner edges. They are small pieces, as you can see, and there are two of each edge. So this is a orange-green edge, inner edge, and this is another orange-green edge. Here's a green-red edge, and here's another green-red edge. Here's a blue-red edge, and here's another blue-red edge. I think you get the idea. Next, we have these corner pieces right here. They are the small layers, and there are not two of them. There's only one. There's only one white, green, red corner piece. There's only one white, orange, green corner piece. And like the same on the yellow, there's only one yellow, red, green corner piece. Finally, we have the center layer. This is the biggest layer and the only big layer. All of the other layers are small, as you can see. This is the only big layer, and it's quite easy to see and easy to move. Now, since you know what the cube is like, let's talk about the steps to solve it. So, once we have it scrambled up like this, the first thing we need to do is solve a cross. That is the first step, and it is a much different cross than you would see on a 3x3. Now, the cross is done. It may look like nothing has happened, but something has, which I will show you later. The next step after you have solved the cross is to solve the corners of the side that you chose, and I will explain more later, do not worry. Now, that's probably the easiest step. The next part, once you have that done, is to solve the middle layer. Once you have that middle layer done like so, then the next thing we will do is solve the top. And just to clarify, guys, I'm not showing you a tutorial yet. I'm just showing you the steps, and I will show you how to do them later. Do not worry, just to clarify. The next thing you do after you've solved the top is you solve this small layer right here. Sorry, this layer, this small one. And when you're done with that, it looks like this. These two layers are solved. The small one right here and the big one right here. That is actually probably the hardest step. That is why it took me so long. The next thing you do is you solve this small layer right here. This one. Now, once you have that done, these three layers will be solved, the middle three layers. The next thing you do is solve the edges of the last layer. The edges of the last layer. And, sorry, I meant edges of the bottom layer, not last layer. Once that bottom layer edges are done, it will look like this. These four edges will be solved. And the next thing you do, solve the bottom layer corners. Easy step. Once that is done, all four of these layers will be done. Well, all five, except for this one. This layer, this top layer, will not be done, and it is also the last layer. The next thing we do is solve this top layer. And once that is done, the cube will be solved, the entire thing. Now remember, that was just explaining what we're doing today. That was not a tutorial. This next part is the tutorial where we will be looking at how to do all those things. Whenever I solve the cube, I always have white at the bottom, the white face at the bottom, and the yellow face at the top. And I suggest you do the same because it makes it much easier to understand. Now, the first thing we need to do is build our cross. This is part of the cube where it is crucial to know how to solve a 3x3. Any 3x3 solver knows how to solve the cross. However, the cross we make on this cube is much different, but uses the same techniques. Not a white cross, but it is a variation of it. For the cross, all you need to do is connect each centerpiece, not including yellow and white, so you don't need to do this with yellow and white, but each centerpiece with one of these small rectangle pieces, these small middle rectangle pieces. You can't connect them with one of these small edge pieces. You have to connect them with one of these small ones. So let's find the blue center. And look, there's already one of them connected. You may have noticed that there are two of each small middle rectangle piece, one here and one here. But that does not matter. You can connect this one, so you can connect this, or you can connect that. It does not matter. Once you have one of those, then you have to aim it towards the bottom, towards the white face, I mean. So these two blue pieces that are connected are aimed towards the white face. Now, you do that with each color. And remember, these pieces do not matter. These top middle pieces, they don't matter at all. So let's find an orange one. It's already connected. So we just have to point it towards the white. So this orange is pointing towards the white. Now, let's use the green one. Let's find a green middle edge. So here's one. We would move it to the top, move that back, and then we would move it down here, connect it to the green, over there. So it just happened to work out that there's a white here, but remember, that does not matter. Now let's do the red one. So let's find the middle edge piece. Here's one. Let's connect it to it, move it to the side, move it down, and then reconnect the green that we messed up. These are using all the same techniques that we would use on a 3x3. So that is why it is crucial to know how to solve a 3x3. I will do one more example of the cross. So we have our white at the bottom, our yellow at the top, and we will start. Let's start with the red one. There's already a piece connected to it, so all we have to do is move it pointing towards white. This red piece right here, this center, and this small rectangle is pointing towards the white, going towards the white. Let's use this blue one. Find the blue middle edge right here. So, as on the 3x3, we move it down and then pointing towards the white. Very simple. Now, let's do the green. Find a green middle edge right here. Move it towards the green, connect it with the green, and then move it towards, so it's aiming towards the white. And it just happened to work out that there was this white piece right here. That does not matter yet. However, that just happened to work out. Let's use this orange one. It's already connected to a small middle edge. So we just point it towards the white. Now, that is our solved cross. We have each centerpiece, not including the yellow and white, connected to one of these small pieces and aimed towards the white. That is what our solved cross looks like. Now, remember, once you have that solved cross, nothing else matters. The bottom doesn't matter. These edges, this top does not matter. All that matters is that we have a centerpiece and a small rectangle pointed towards the white on each side. The next thing we are going to do is solve these white layer corners. So, what I mean by that is we are going to fill in each corner of the white layer with white. Now, this also uses 3x3 techniques. So, you find a corner. Here's a white corner. It has to be a white corner, not a yellow corner. And remember, these yellow pieces do not matter, or these colorful pieces don't matter either. Okay, all you have to do for this is solve the corners of the top layer like you would do on a 3x3. So I find a white corner, and then I insert it like I would on a 3x3. I find another white corner. I insert it. I find another white corner. I insert it. And as you see, all of the corners are inserted. I don't suggest using F2L on this cube. It confuses you a lot. I tried it and it doesn't work. It sort of just messes you up. So don't use F2L. So when that step is done, you have the cross and the white corners. These yellow pieces don't matter. Nothing else matters. The next thing we are going to do is solve the middle big layer. Here's our white. We're going to solve the middle. So, we usually use the beginner's method. You can use any method you want, but I'm going to use the beginner's method. It's exactly the same. You just find an edge. So this is orange and green. So it needs to go in between the orange and green, just like you would know on the beginner's method. And then you do that algorithm. If you do not know that algorithm, I will put them in the description and I will also explain them a little. So if you don't know the beginner's method, then you can watch this. So I will put algorithms in the description, but also on the screen. All you need to do is find one of these big edges, and there aren't that many. There's only 4 on this cube because they need to go 1, 2, 3, 4. There's only 4 slots for them. So find one. Here's our red and green one. It needs to go in between here. So you can see that red is on the top. Red is on the top of this edge piece. So you connect it to the red, as you can see. And then since it needs to go in here, you do this algorithm, which I will show you right now. Now remember, this is the front face. You have your edge on the right side of the cube. And as you can see, that edge is inserted. That is only one of the cases. There are 3 cases that could happen. Here's another case. We have our red and blue, but instead our red is on the top again, but blue is over here on the right. You would also hold this as the face. You always want to hold this, your left color, as the face. So we have red on the top, we connect it with red, blue is on the bottom, we need to move it in here. Last time we had blue on the top, so this would be blue, but then red would be down here. But this time we have red as the top. So what would we do is this algorithm. And that inserts it, like so. The next case is when you have one of these. They are flipped. All you have to do is hold it like this, so the piece that is flipped is on the right side, and then do this algorithm. And there you go. That entire middle layer is solved. Nothing else matters except for the middle layer, the cross, and our top layer corners. Our next step is to solve our yellow layer. Our yellow top layer. This does not mean that we are solving the entire thing. It just means that we are making it available to move. So, I'm not going to explain this because you should know how to solve a 3 by 3. But since this middle layer is done and we have the cross, we're solving this layer. And then you use any method, the method that you know, to solve the top layer. Now, something I was very confused on. This, you have to look at the top layer as if yellow and white were the same color. So, if yellow and white are the same color, that's what I was confused on when I was learning. I thought that this was just a line, that we just had to look at yellow. But no, we have to look at yellow and white as the same color. So next thing we do is we would just solve it like we would on a 3 by 3. And when I say solve it, I mean so this layer is available to move, and the top layer and bottom layer have only yellows or whites. Each one has only yellows and whites. So now every layer is available to move. The next thing we are going to do is solve this small layer right here. The layer that is closest to the white. So this small layer. There may already be some pieces solved. Right now, I don't have any because I just don't happen to have any. But the way we are going to be getting those pieces correct is by using the pieces in this small layer. This one right here. The pieces in this layer, just find any piece. So I'm going to use this orange and green piece right here. And I'm going to bring it over the orange and green. So right here is the orange and green. So I'm going to bring it in between like that. So this is the green and red. So we have to put it in between here. So it was already in its correct place. This is orange and blue. So we would bring it over orange and blue. You may realize that there are two of each. So here's an orange and blue and here's another orange and blue. The way you figure out which one is correct is by bringing it over its correct piece. And you see this one lines up. This one does not line up. You are actually going to use the one that does not line up. You want your cube to look like this. You do not want your cube to look like this. The reason is, when we use an R2 in our algorithm, it brings it so it's correct. Like that. Blue is on that side and orange is on that side. So, when you have a piece, such as the orange and blue piece, you bring it over the orange and blue and make sure they're opposite, and then you do this algorithm. Now, you may have realized that after that we've done that algorithm, this piece is now in the correct place, the orange and blue piece. However, these are switched. That does not matter. The only thing that matters is that you keep using the same face that you used to do that, to fix the orange and blue. What I mean by that is we have the green and orange piece right here. What we would do is we wouldn't put it over the green and orange. We would bring it over here. We would bring it one space over here, because from where we did our orange and blue, which is right here, and it is in the correct place, green and orange is one place over. So we would bring it over, and then bring this piece over, and then use the same face as the algorithm to do the algorithm. And the reason that the algorithm fixed itself is because we reversed it. We did R2, we did the algorithm twice, so it reversed itself. Now you see, if you bring it back, these two will be solved. The next thing we do is solve these two. We do the exact same thing. We find any edge, so I'm just going to use this red and green one, bring it over the red and green, and they are opposite. So I do the algorithm. and then you see it's in its correct place. So the next thing, we need a red and blue. So we find the red and blue piece, which is right here, red and blue. We see if it's the correct one, red and blue, and they are opposite, so it is correct. We bring it over here because we need to use the same face. So instead of going here, we bring it over here. And then we see that the red and blue is one space over from the green and red. So we bring the bottom layer over one space too. And then we do this algorithm. And you see our entire, this entire layer is solved. Now, you might get a case like this, where one of them is solved, and none of the others are. So, what you would do is you would solve it like you normally would, but then you would get to this point where there's none left in this layer that you could use. What you would do is that you would see in this top layer, there's a middle edge piece right here, another blue one. The reason we need that is because we need to switch these two, but when we do that, we mess up this blue edge. It needs to be back down here. So what we would do is we would leave it in that position, and then we would connect the extra middle blue edge with the blue side, or the side that you messed up, and then you would reverse it. So you still have this cross made. And then you carry on. You may also get to a point where the two or the few that we need left are in the wrong positions, like this needs to go here and this needs to go here. What we would do is we would use any of these top pieces that we don't need right now, and we would put it into one of these slots. Now you see that the piece that we needed over here, which is this one, is now available to place in like normally. So you would move it over here, and then you would move this over here, and then you would do it. And then you would continue on doing it normally. Now, when you are done, you may find that the entire bottom layer, this entire small layer is done, but these need to be switched. You cannot do this. That would just mess up this. So it does not, I'm just telling you right now, it doesn't matter. That does not matter right now. We are going to fix that later. Now, that's probably the hardest step. Watch it a lot, and if you don't understand, then it's okay, because I do know that that's a very hard step, and it took me a while. The next thing we are going to do is solve this other small layer. So when we are done with this step, this will be solved, this middle layer will be solved, and this small layer will be solved. The reason this middle layer will be solved, if you have one of these, and I told you that it doesn't matter, is because in the end of solving this small layer, then we are going to fix this. It is called parity. If you have this little layer is mixed up like this, you just random, you find headlights. You find these headlights, and headlights are when you have either all the same color or two of the same color, but they are opposite, and then there's one color in between, such as this. And if you have no headlights, it is okay. Just do this algorithm from anywhere. If you do have headlights, then do this algorithm and put the headlights on the left. And then if you didn't have headlights, then you will find headlights, and then you can just do that algorithm again. Our first case is when we have two adjacent edges, like so. This red edge is in between the blue, and this blue edge is in between the red. We need to switch these two middle edges. These two edges over here are already solved. One more thing I should mention is if you have these that are opposite, if you don't worry about this, but if you do, which you will sometime, then keep using this face that has the two that are switched on the right side. So switch and switch. You keep using this face. So if you have headlights, like I just showed you, then you should put them on the left of this face and have this turning as when you're doing the algorithm. So keep using this face. Our first case is when we have two adjacent edges. This blue is in between these reds, and this red is in between these blues. So these two middle edges need to switch. These other two are already solved. So I'm going to put one of them right here and the other on the right. We don't want any over here. And I'm going to hold it with this as the front because I need these two to switch, which we will do later, but I keep using this face right here as the front. So I put them like I would normally. And if you don't have this, then you can just put them anywhere, but make sure there's always one on the right and one in front. But I'm going to use this because I have one of these that need to switch. You would do this algorithm. And then you see if you had one of these that were switched, then it switched around. Another thing that is possible is if we have one here and one here. These two middle edges need to switch. This red needs to come in between these two reds, and this orange needs to come in between these two oranges. These two, on the other hand, are solved. So the algorithm we would use here, if you have one of these switched ones, then keep using this as the front face, and put one in the front, one that needs to switch in the front, and the other that needs to switch in the back. And then do this simple algorithm. And you see, this whole small layer is now solved, and so are the ones that were mixed up, if you had them. It is also possible that you could get a case that you would use on a 3x3. On a 3x3, this needs to switch with this, and this needs to switch with this. So you would just use anything you know from a 3x3 if you have one of these algorithms. So you would use what you would do on a 3x3. Okay, so when you are done with that, you may see that you still have these, or that you just got them. So what you would do in this, it's just a simple parity algorithm. You would hold the two that you would need to switch, green and blue, in the front. It has to be in the front, like this. And then you would do this algorithm. And then, once you're done with that algorithm, you just turn it around, and those three layers are solved. Another thing, when I say in the algorithm, when it says U2, I only mean this small layer. Only this small layer. When it says U, lowercase u2, then that means these two layers. The next thing we do is a very simple step. We solve the bottom layer edges. This is very simple. All you have to do is on the top layer, find any edge, so any white edge. Here's a white edge, white and red. So then you would find the red face, put the edge on the left or right of the red face. Well, if it's red, that is. You put it on the left or right of the face. Then you would turn this face, bring the red over, and then put it back. Now you see that solves one of our edges. Now you just do that with all the edges. So here's a white and green edge. We find the green, which is right here, put it on the left or right, so it's on the right already, and then we would turn this, put it over, and then put it back. Here's a blue and white edge. We find the blue face, put it on the left or right of the blue face, so I already have it on the left. Turn this blue face from the side, connect the blue, like that, and then turn it over. Now, here's our final edge, white and orange. We do the same thing. Orange is on the right, and here's the orange face, so we need to put it in here. Do the algorithm. Well, not really an algorithm, but just moves, sort of intuition. And there you go. All of your bottom layer edges are solved. The next step is solving our bottom layer corners. This is a very simple step. All you do is you find any white corner that is on the top, and then you would move it to its correct place. Now, the reason this is very easy is because there are not two, like we did on this layer, but there's only one of each corner. So you see there's only one white, blue, red. So it's obviously going to be correct because these two are opposite, just like on this layer. So you would just do the algorithm. But in this algorithm, you wouldn't use these two layers for the U, you would use only this layer. So I'll show you. R2, U, only this layer. R2, U prime, only this layer, and then R2. And then, you see this is in here, and you would do the exact same thing you would do on this. You find another edge, or corner in this part. You see that it is white, orange, green. And the orange and green is over here. We know that this piece is correct because there's only one. We would move it over here because we need to switch these. We keep using the same face. And then we would move this bottom layer over 2 because the orange and green is 2 over from the blue and red. So, and then we would do it. So now, we would finish all the white corners, all the white bottom corners, like we would this one. So, we'd hold the parity on the right, and we'll ignore that for now. And now we see that this white piece is white, green, red. White, green, red is one space to the right. So we bring this right here. We bring it this there, and then do the algorithm. Remember, when you do the algorithm here, you do a U as just this layer, not this layer. And now, we find this. We see that this is white, blue, orange. We put it over the white, blue, orange. We do the algorithm. We see this one. We see it's white, orange, green. White, orange, green is one space to the left. We bring this over. So this is on top of it. Do the algorithm. And then you'll see that these 4 layers are solved. You might have a case where this is still, like these are still like that. It doesn't matter for now. We're going to fix that later. So if you have that, don't worry. We're going to fix it later. You could also have one of these cases where there are no whites on the yellow layer that you can put down here. That is because these are in the wrong places. So what we have to do is just take one of them and then we switch one of the ones that are wrong with any yellow piece, any yellow corner. So we would do that by doing the algorithm. Now you see that one of the whites is up here. This is the white, blue, orange piece. White, blue, orange is one to the right. So we bring this over, put this on top of it, and then do the algorithm. And now you'll see that this is in the right place. All we need to do is that. And the final white is up here. It is white, orange, green, and it's already over the white, orange, green. So we just do the algorithm. Now, this small layer is solved. You might have this, but your entire 4 layers might also be solved. It doesn't matter if you have this. We're going to fix that later. Now, we are on to the final step of solving this last layer. Like me, I got a skip like this, and you could have gotten that too, but right now I'm going to go back one step so I can show you guys what to do. Okay, as you can see, I've gone back one step, so now this top layer isn't solved, and we have headlights. So just like in this layer, we're going to find headlights, if you have any. You might not have any. And then you're going to put the headlights on the left, if you have any. And then you'll just do the algorithm. Now remember, the U's and D's in this algorithm, whenever we do a U move, like that, then we're only going to use this layer. And then whenever we do a D move, like that, we're only going to use this layer. Not these two, like we did earlier, and not these two. So, if you have these, put your headlights on the left of them, keep this as the front face, and you do the algorithm. And And as you'll see, you now have all either headlights or just something else. And if you didn't have headlights, you now have headlights, and you can do that algorithm again. Once you're done with that, we have two algorithms that we could use. One of them is one that switches this and this. So if you hold this as the front, and then you do this algorithm, then it would switch this and this. So I did that algorithm holding this as the front, and it switched these two. So what you do is from anywhere, you can do that algorithm, and as you can see, it now gave me these two, which could be switched easily by doing that algorithm. This yellow and blue needs to come here. This yellow and orange needs to come here. So we just need to switch those two. Keep these at the front because we have the parity, like you can see. And you have this, and then the other one on the right. And then these two could be solved. And then you just do the algorithm. And then once you're done with that, the cube is solved. There could also be another case and another algorithm where these two need to switch. So if you hold this as the front, this would switch with this, and this would switch with this. So as you can see here, we need this yellow and orange to switch with this yellow and red, because this yellow and red needs to come between here, and this yellow and orange needs to come between here. So we would do this algorithm, holding this one in the front, one in the back, and then we would hold the parity over here on the right. And there you go. The cube is solved. Now, you may think that because when we did this layer, then we could use 3x3 algorithms. In this layer, you cannot use 3x3 algorithms. As you can see here, we have these two wanting to switch and these two wanting to switch. The thing is, we can't use the 3x3 algorithm for this because it would just mess it up. What we'd have to do is we'd have to use the adjacent edges algorithm on each of these. So right here, we hold it right here. This needs to switch with this. This needs to switch with this. You can hold it either way. Like, you can hold it like this because these two need to switch, or like this because these two need to switch. And then you would do the algorithm twice. And when I say twice, I mean do it once at first, and then have these two come over, and so these two need to switch, and then do the algorithm again. And there you go, cube is solved. You could also have one of these, which is also a 3x3 algorithm, where this needs to switch with this needs to switch with this needs to switch with this. So it'd be going like that. We can't use the 3x3 algorithm. We have to use one of those two algorithms. In this case, if we did the adjacent edges, it would switch these two. This would be green, this would be red. So that would mean that these two would need to switch, and then that would solve the cube. So when we do that algorithm, it switches these two. When we do the other algorithm, it switches these two. So when you have these three that are these three headlights, and then this one in the back correct, then you do the adjacent edges algorithm from here, and then you'll find that you could either have an adjacent edges or these two that need to switch. Right now, I have these two that need to switch because this red and yellow needs to come here, and this yellow and orange needs to come here. So we do that algorithm, keeping this as the front because we still have the parity. And then the cube is solved. If you have a case on this top layer, which you don't know how to solve, then just mess around with those two algorithms, the adjacent edges and the opposite edges, and then you'll find either that you have adjacent edges or opposite edges. It's quite a simple layer, and you can figure most of that out yourself, which is why I didn't teach you too much about it. And once you're done with that, the entire cube has been solved. I'm now going to go over a few things that you should remember. For the cross, many people think that these white pieces matter. They think that this white and red piece right here, they think that this piece needs to be orange because it needs to be connected, like a 3x3. However, that does not matter. These edge pieces don't matter. All that matters for the cross is that this center is connected with a small rectangle of its color, and those two are pointed towards the white center. Many people also think that for when we are solving the corners of the white side, then they think that each white corner has a specific place. They think that maybe this white, blue, and orange needs to go here, but they don't know where. However, all you need to do is just place the corners anywhere. So this white corner, it could go here. It could also go over here. It could go anywhere. It could go in either 4 of these slots. So this one, it could go here. It could go here. And this one could go here. It could go anywhere. There's nothing to go over for the middle layer. It's pretty simple. This is a big one. When you are solving this top layer right here, the yellow layer, we have to remember that yellow and white are the same color. They act as the same color. So these whites pretend that they're yellow. These whites pretend that they're yellow. And you just solve it like you would on the 3x3. Now, for this small layer, this is the hardest layer. Remember, watch this one over and over until you get it. It will be hard, don't worry. We have to remember this would be correct because this orange is on this blue and this blue is on this orange. The only reason it would be correct is because when we bring this down and when we do the algorithm, this blue is on the right side and this orange is on the left side. So when we do that algorithm, then this is in the correct place. Now, remember, they have to be opposite. This is correct. But if we go find that other orange-blue piece, which is right here, it would be correct. We don't want that. We want this orange-blue piece that is opposite. Remember that when you do that, this will happen. Don't worry about that. Only worry about keeping this as the front face. Keep this as the front face. The only time we would use parity, the parity algorithm, is when we have this small layer solved, this small layer solved, this big layer solved, but then we have these 2 pieces. That's the only time that we'd use the parity algorithm. All the other times we would ignore it, but keep it on the right side. For this small layer, there's really nothing to go over. It's a fairly simple layer, just keep practicing it. Some people have a hard time with it, but just keep watching the video. There's also nothing to remember for this layer, this bottom layer. It's a very simple layer, and it should be very easy for you to memorize. For this very top layer, you may have noticed that I didn't explain too much. All I explained was what those algorithms did and how to use them. However, I think that you can figure those out yourself. They're very simple. I figured them out in just a few minutes. So I think you should be able to figure it out. Just keep trying, and if you fail, try again. Well guys, that is the end of my 3x3x5 non-proportional cube tutorial. If you have watched it this far, good job. Keep watching the video if you don't get it. I know it's kind of hard and difficult, but believe me, you'll get it after a few days. It took me a while too, but remember, don't give up. It's a really cool thing to know how to solve many cubes, not just a 3x3, other cubes such as this one. That's why I made this tutorial. Thank you for watching guys, and I'll see you in my next video.